So next part of the lesson is about graphing piecewise function. So in plotting the points, we have some guidelines. So if the inequality symbol of the interval is greater than or equal to or less than or equal to, use shaded point. It means that the given value is included. Next, if the inequality symbol is greater than or less than, use hollow point. It means that the given value is not included. So three grouping symbol for domain and range. Bracket means included, parenthesis means not included, and braces usually used if the function is constant. So these are the steps in graphing piecewise function. So given the piecewise function, first divide the piecewise function to its subfunction. Second, graph the subfunctions. Third, combine the graph. And lastly, cut the graph according to its interval. Consider the intervals, then find the domain and range. So for example, we have the piecewise function f of x equals x minus 3 if x is less than negative 1 and 2x plus 1 if x is greater than 1. So step 1, divide the piecewise function to its subfunction. So we have two subfunctions. F of x equals x minus 3 if x is less than negative 1 and f of x equals 2x plus 1 if x is greater than negative 1. So next, graph each subfunction, okay? So since both subfunction is linear, so we can expect that we will be having two slanting lines, okay? So first subfunction, use the y and x intercept of the function. So we have y equals x minus 3 since f of x and y is the same. So in finding the x-intercept, we will change y to 0. So therefore, 0 equals x minus 3, x is equal to 3. So the first point is 3, 0. Next one, the y-intercept, change x to 0. So y equals 0 minus 3. Y equals negative 3, 0. Or 0, negative 3. So next, graph. So we have the 2 points, 0, negative 3, and 3, 0. Then connect. So this is the graph, the first subfunction. Next one, the second subfunction. So again, we'll be using x and y intercept of the function. So y equals 2x plus 1. X-intercept, change y to 0. 0 equals 2x plus 1. X equals negative 1 half. So the first coordinate is negative 1 half 0. Next one, y equals 2x plus 1. So y-intercept, change x to 0. So y equals 2 times 0 plus 1. So 2 times 0, 0, y equals 1. So the second coordinate is 0, 1. So we will be graphing the second subfunction. So given the 2 points, negative 0.5 or negative 1 half, 0, and 0, 1. Connect the 2 points, extend. So we have now the two graphs of the subfunction. So next step, combine the graph of the two subfunctions. So the red one is the graph for the first subfunction, while the blue one is the graph of the second subfunction. So it looks like this. Step number 4, we need to cut the graph according to its interval. Okay, so in finding the interval or in cutting the graph according to its interval, we will consider its interval. So we will just substitute negative 1 to the function. So it will become y equals x minus 3, y equals negative 1 minus negative 3. So y equals negative 4. So negative 1, negative 4. So y equals 2x plus 1, substitute negative 1. So y equals 2 times negative 1 plus 1, negative 2 plus 1, therefore negative 1. So our conclusion, we will cut the first graph at exactly or in the point negative 1, negative 4, while the second graph is negative 1 and negative 1. So let's do this. So this is now the graph. So the first subfunction, since it is x is less than negative 1, so negative 1, negative 4, we cut, okay, and negative 1, negative 1, so it looks like that. Okay, so next is we need to find the domain and range of this graph. So in finding the domain, we need to look at the x-axis. Okay, so the x-axis. While for looking for the range, we need to look at the y-axis. So first, we have the first subfunction f of x equals x minus 3. So domain, look at the x-axis. So we can see that the graph is extending downward and to the left. So therefore, the x values to the left, so negative. So it is extending, so it can be extended infinitely. So therefore, the domain is from negative infinity to the point where the graph is cut. So from negative infinity to negative 1. While the range, so we can see that the graph is extending downward. So from negative y values, so negative infinity, to the point where the graph is cut. So negative 4. Okay. Next naman, the second graph or the second function. Second subfunction. So from negative 1, we can see that the graph is extending upward and to the right. So therefore, the x values to the right are the set of positive values. So from negative 1 to positive infinity. While the range is from negative 1 upward, so positive y values, so positive infinity. So next, we will combine the domain and the range of two function or two subfunction. So we will be having in the domain negative infinity to negative 1 union to negative 1 to infinity, positive infinity. While the range, negative infinity to negative 4 union negative 1 to positive infinity. So we will be using union in combining set. Okay? So take note of this. Since the inequality of the two subfunctions are less than and greater than, so we can see it in the interval, the point is hollow. Okay? So in the guideline a while ago, since it is a hollow point, it means that it is not included. And the symbol used is parenthesis. Okay? So we can see that the intervals is just less than or greater than, so we will be using parenthesis. In positive or negative infinity, we always use parenthesis. Okay, so that is number 1. So next example. So the second example, we have the piecewise function f of x equals 2 minus x, 3, and x plus 2. And their interval, x is less than 0, x is greater than or equal to 0 but less than or equal to 1. And last, x is greater than 1. So we divide the piecewise function into its subfunction. So we have now f of x equals 2 minus x, where x is less than 0. F of x equals 3 if x is greater than or equal to 0. Sorry about that. And lastly, f of x equals x plus 2 if x is greater than 1. So graph each subfunction. Use the x and y intercept the function for the first and third subfunction, since the first and third subfunction is linear while the second is a constant. Okay. So the first one, using x and y intercept, y equals 2 minus x. X intercept, change y to 0. So 0 equals 2 minus x, x equals 2. So the first coordinate for the first subfunction is 2, 0. Next, y equals 2 minus x. So y intercept, change x to 0. Y equals 2 minus 0, y equals 2. Therefore, the second coordinate for the first subfunction is 0, 2. Okay? Yan. So, we will now graph. So the first point, we have 2, 0. And the second point is 0, 2. Then connect. So this is the graph, the first subfunction. Next, the second subfunction, f of x equals 3. So the second subfunction is a constant function. So the graph looks like this. So it looks like this. Okay, so sorry about that. At point 3, we just draw a horizontal line. Okay. Next, the third subfunction, f of x equals x plus 2, where x is greater than 1. So we will be using x and y intercept again. Y is equal to x plus 2. X-intercept, change y to 0. 0 equals x plus 2. Therefore, x equals to negative 2. So the first coordinate of the third subfunction is negative 2, 0. Next one, y equals x plus 2. Y-intercept, change x to 0. Y equals 0 plus 2. Y is equal to 2. So therefore, it will become 0, 2. Then graph the third subfunction. So the 2 points, negative 2, 0. 0, 2, connect, extend. So next step, we will now combine the graph of the three subfunction. So the red one, the blue one, and the green one. Okay, so this is the graph, or this is the combination of the graphs of the three subfunction. So step number 4, we need to cut according to its interval. So substitute the value of the interval to its function. So 0, y equals 2 minus x, it will become y equals 2 minus 0. So 2 minus 0 is 2, y equals 2. So therefore, the first point is 0, 2. So we will cut the first subfunction in the point 0, 2. Next one, since this one is a constant, the points is just like this. So 0, 3. So the first interval, or so the first critical value rather, so 0 and 3. And the second critical value 1 and 3. Okay. Next, y equals x plus 2. So y equals 1, substitute to the function y plus 2. So y equals 3. So the point is 1, 3. Therefore, the first subfunction will be cut to the point 0, 2, while the second subfunction will be cut to the points 0, 3 and 1, 3. And lastly, the third subfunction will be cut to the point 1, 3. Okay. So this is now the graph of the piecewise function. So we can see the first subfunction, we use hollow point. Okay, since it is less than only. While the second subfunction, both solid point rather, because we have greater than or equal to and less than or equal to. And the third graph is a hollow point. It's just overlapping to the point of the second subfunction, but it is a hollow point. So when a hollow point and a solid point overlaps, it will become a solid point. But in the third subfunction, it is hollow. Okay. So now let's get the domain and range. So for the first subfunction, the red one, we can see that the graph is extending upward and to the left. So therefore, in finding a domain, we will look for the set of x values. So we can see that the x values goes from 0 to negative numbers. So therefore, from negative infinity to 0. And we use parentheses since the inequality is less than. And the range is from 2 upward. So from 2 to positive infinity. So again, we use parentheses since 2 is a hollow point. Next, y equals 3. So from 0 to 1. Okay, so domain is from this line, so x equals 0 and x equals 1, so 2, 0, 1. So we can see that it has both brackets. Okay, because the interval has the inequality symbol of greater than or equal to and less than or equal to. Next one, the range. So we can see that the line just lies on the point 0, 3 in the x-axis. Next one, y equals to x plus 1. So from 1, okay, so from 1 to positive infinity. And the range is from 3 to positive infinity. Next, we will combine their graph. Okay, so we can see in the domain or the set of x values from negative infinity to 2. Okay? Again, from negative infinity to 0 rather. Then we will go up 0 to 1 to positive infinity. So we can see that it covers all the x values. Okay? So therefore, the domain of the piecewise function is from negative infinity to positive infinity. And next, the range. Look at the whole piecewise function. So from negative 2, from 2 rather, upwards. Okay? So the range is 2 to positive infinity.